All right, we got a real quick lesson today, nice and sweet. So our lesson today is testing the mean mu. Cool. All right. So in this section, we continue our study of testing the mean mu. The method we're using is called the p-value method. It was used extensively by famous statistician R.A. Fisher. Hey, how you doing? I'm happy when I see y'all with food. That's what's up. All right. And is the most popular method of testing in use today. At the end of this section, we present another method of testing called the critical region method or traditional method. The critical region method was used extensively by statisticians Neyman and Pearson. In recent years, the use of this method has been declining. It's important to realize that for a fixed present level, level of significance alpha, both methods are logically equivalent. All right. So let me just break this down a little bit, right? You can make your decision when you're doing hypothesis testing from drawing a graph and using the traditional method, right? The thing is, though, right, that method works for the normal distribution. Every time you switch a distribution, right, say you go to chi-squared or one of these other distributions, right, you have to learn that graph and then you can do that traditional method again, right? Whereas with the p-value, every graph, every distribution has a p-value. It's the same concept, the same idea, right? So if you use the p-value, you know how to work it for all test situations, right? But if you're using the traditional method, you're gonna have to learn new graphing techniques and all of that. Logarithmic, linear, right? All that good stuff from Math 28, right? Okay. So, um, in the next section, right, we discussed the vocabulary and the method of hypothesis testing using the p-value. Let's quickly review the basic process, right? So these are our 5 steps, right? I'm sorry. So we first stated a proposed value for a population parameter in the null hypothesis, right? So that's the HO. The alternative hypothesis H1 states the alternative values of the parameter, either less than, greater than, or not equal to the value proposed in the null hypothesis, right? We also set the level of significance alpha. This is the risk we're willing to take of committing a type 1 error, right? That is, alpha is the probability of rejecting the null hypothesis when it is in fact true, right? We use a corresponding sample statistic from a simple random sample to challenge a statement made in a null hypothesis. We convert the sample statistic to a corresponding value of the appropriate sampling distribution. We use the sampling distribution. This is step 3. We use a sampling distribution of the test statistic and the type of test to compute the p-value of the statistic, right? Under the assumption that the null hypothesis is true, the p-value is the probability of getting a sample statistic as extreme as or more extreme than the observed statistic that from our random sample, right? Step 4, we concluded the test. If the p-value is very small, we have evidence to reject the null hypothesis and adopt the alternative hypothesis, right? What do we mean by very small? We compare the p-value to the preset level of significance alpha, right? So if the p-value is less than alpha, then we say that we have evidence to reject the null hypothesis and adopt the alternative hypothesis. Otherwise, right, we say that the sample evidence is insufficient to reject the null hypothesis. Finally, we interpret the results in the context of the application. That was all what we did yesterday. Those are our 5 steps. All right. So knowing the sampling distribution of the sample test statistic is an essential part of the hypothesis testing process. For test of mu, we use 1 or 2 sampling distributions from the sample mean, right? The standard normal distribution or student's t distribution, as discussed in chapter 7 and 8. The appropriate distribution depends upon our knowledge of the population standard deviation sigma or the nature of the X distribution and the sample size. All right. So let's talk about testing mu when sigma is known, right? In most real-world situations, sigma is simply not known. However, in some cases, a preliminary study or other information can be used to get a realistic and accurate value for sigma, right? So here's our procedure. How to test our population mean mu when sigma is known, right? Requirements: let X be a random variable appropriate to our application. Obtain a simple random sample of size n of X values from which you compute the sample mean X bar. The value of sigma is already known, perhaps from a previous study. If you can assume that X has a normal distribution, then any sample size n will work. If you cannot assume this, then use a sample size of n greater than or equal to 30. All right, so procedure, step one, in the context of the application, state the null and alternative hypothesis and set the level of significance. Level of significance is given to you in the question, so you just have to write it down. All right. Step two, use the known sigma, the sample size n, the value of the sample mean, right? X bar from the sample, and mu from the null hypothesis to compute the standardized sample test statistic, which is a z-test, X bar minus mu over sigma over square root of n. Same thing that we did in chapter 7, right? Step 3, use a standard normal distribution and the type of test, one tail or two tail, to find the p-value corresponding to the test statistic, right? Conclude the test. If the p-value is less than alpha, then reject the null hypothesis. If the p-value is greater than alpha, then do not reject the null hypothesis, right? Step 5, interpret your results. Cool, right? So we got the rules read to us twice. Now you guys are up. Here's your example. All right. Sunspots. This is an example, right? Sunspots have been observed for many centuries. Records of sunspots from ancient Persian and Chinese astronomers go back thousands of years, right? Hold on a second, because I did not know that. 1 second. Okay. Some archaeologists, right, think sunspot activity may somehow be related to prolonged periods of drought in the Southwest United States. Let X be a random variable representing the average number of sunspots observed in a 4-week period. A random sample, right, of 40 such periods, right, from Spanish colonial times gave the following data, blah, 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 right? With the sample mean of X bar is equal to 47, previous studies of the sunspot activity during the period indicate that the standard deviation was 35. It is thought that for thousands of years, the mean number of sunspots per 4-week period was about mu equal to 41, right? Sunspot activity above this level may or may not be linked to gradual climate change. Here's the question. Do the data indicate that the mean sunspot activity during the Spanish colonial period was higher than 41, right? Use a level of significance alpha equal to 0.05. Go ahead, do it. Can I do it on the board? Go ahead. Just don't write on this part right there behind me. I'd probably be a lot more funny if this really was beer. Yeah. Mhm.
Perché non basta, sbagliata.
I don't really need all that.
Provare
That's all you need. So everybody in the back can see.
guarda lungo dove vedo.
Okay, so what you doing right now?
I just um
You're writing down what?
Yeah, I'm writing each number with x bar equal for 7.
Okay. So you're writing your information from the
Yeah,
question.
right.
Okay. Y'all could work with him, it don't have to be him by himself.
That's all.
Mhm.
Yeah, and. It's always something that happens. Let me see. And 41. No, what is happening? They were waiting. No. No. I was in 4. Then look at your mistake. Look what you wrote for the, it's 40.
And it's 41. Are you sure? Well, population mean is 41. That is population mean. This is segment standard deviation is x bar, and this is alpha.
Look what you
And
wrote.
I think it's
Look what you wrote. Look what you wrote.
where and you population mean
And.
and n is not 4. I'm not sure if that's what I need to check. If it's 4 week or it is 41. No, but the population mean is 41.
No, not so. Oh, I would say.
You could go up.
Oh, well, I guess I know.
Which one is n here? I'm confused.
You tell me.
God, wait.
I need the extra help.
I thought it was 41.
You thought N was 41?
That's the
You
population.
thought N was 41? How did you know that?
If you count.
We're good.
It's 40.
That's how I know she's gonna get 100. She actually read it. Wow.
It's 40.
Counts it, it's 42.
That's how I know you're gonna get 100.
Yeah, it's 40.
And it's 40.
Mhm.
Why n is 40? Can someone explain? Oh, yeah, I didn't see the question. Oh, yeah, because that's why I didn't see a random sample of 40. Yeah, yeah.
Well, also.
That's why it's true.
4, 8, 12, 16, 22, 28.
Sure, it's true now. Okay, we just need to plug it in now.
See, this is where I just have box cards.
Whoa. You on step 2. What happened to step 1?
Huh?
What happened to step 1?
Is step 1?
Yeah.
Is
Oh.
plug it in. That's it.
That's not step 1.
That's no step 1. Oh, 8 so.
Right.
Oh.
Mhm. Mhm.
Oh. Step first.
None of these black markers work.
It's not working. So more.
None of these possible.
Are not working. I don't know. It's not on step first. And didn't want to. So no hypothesis equal to you.
This is here.
I have to write a page. I no hypothesis equal you. I don't know.
I'll give those. Yeah, that's.
I think this is higher than is left tail or right tail.
Left tail is, to this face, so I need this.
I think
Less.
higher than is higher than is I think is right tail. Greater than is right tail. Left tail
Is less.
is higher than or less than? I think it's less
Just
than.
read it, it says higher than, so that means it's to the right, yeah. The highest to the right.
Higher, oh,
So
right
like,
tail.
number table, like.
Oh, right is, okay, it's right tail, so it or greater than it's.
See, when I do like this, I just, when I love myself. You got it.
Right, that's the first step. Now we have to calculate.
Then what do you plug it in?
Yeah. Do it.
No, that keep, we won't get the number.
Alright.
All right, so we got mu is equal to 41. Mu is greater than 41.
No,
Higher is left tail or right tail? Higher than is right tail, right?
So you're right, so
Okay.
if this was a test, you would have got this wrong.
What?
Hey, it
Why?
has to say what? What's missing right before the greater than?
Equal?
I know.
Can I get a pen?
You don't have one?
No, I just came in.
Hey, now
Why
you just
didn't
came in, man. How you gonna take notes for today?
Do we got a test today?
Nah,
When?
it's gonna be next week on Monday.
What is missing here?
You tell me.
Someone know?
What's
what
missing?
is
What's missing in the alternative hypothesis?
right here? Equal? No, it can't be equal. We don't use equal here.
What is greater than 41?
Oh, the other symbol?
What's the other symbol?
Like this?
No.
that's-
What is
that's
greater
it.
than 41?
I don't know. You
no,
made it. Yeah.
There's a
So-
symbol that's missing.
Oh, it's like, no, that's when it's two,
No.
when it's two tail. That's only.
No,
two
there's
tail.
something, the greater than is right. Something is supposed to be before it.
The, what, they say. Car? No.
That's true.
No.
No, but that was.
Look at the top. The null hypothesis is correct. What does it say? What does the null hypothesis here say?
the null hypothesis. The null hypothesis is 40.
What is 40? What's in front of it?
Oh, equal.
What's in front of that? That's not n. What is that?
H one? I
No.
don't know, where you are.
What?
I don't know.
Look, you see the null hypothesis HO,
Yes.
right? What comes after that? Mu.
No, depends on statistic, no, we don't know, we're not talking about that is.
No, that is it. Mu is missing.
Huh?
Mu is missing. Right here.
That's what I said?
Yeah.
Oh.
Here, one of these. Right, that's what's
Oh,
missing.
the Z.
Not the Z, no.
We have.
Oh, but then.
Oh. Yo, come do it.
then-
Cause you got it. Come on, man. Yo. Right, in front of the
Oh,
H1.
the N,
Oh,
the U.
yeah.
Okay.
It's already there in front of the zero. It's supposed to be in front of the H1.
Oh. And in the first one, is
The first one is correct. That's
Okay.
fine.
oh, and then.
Good. That's it.
Got it.
All
Okay.
right. And yes, you'd got marked off for that. All right. That's step one. What's step two?
Do I get it?
I'll take that. What kind of test is this?
A Z test.
All right, go ahead, do it.
Cause you know what, because you know what,
I feel you in that. All right, let me copy what they're doing so it'd be a little more clearer, all right? Y'all could just yell out the window and be like, yo, stop. Because I know there's other spots on campus that they could be shaving right now. Yeah. 20, nah, they make way more. They making bread. Yeah. Look it up. You have to Google it. But it's bread though, man. And we ain't even talk about the overtime or nothing. Yeah. So for HO, mu is equal to 41. H1 mu is greater than 41. All right. That's step one. Step two. I heard somebody say this was a Z test. So X bar minus mu over sigma over the square root of N. All right, finish it.
When you try to tell where is going mu, but the lower bound is going in 1e99, negative 1e99, and the and the X bar is going upper bound.
Let me see.
I don't know, I'm not sure. It's a little complicated.
Oh, for doing this, I got you. It's greater than, so infinity is on the upper
I
bound.
think it's going to the upper bound.
Yeah, upper bound is infinity.
Yeah, they got.
I got a question. I'm playing this right?
Parentheses.
Oh, the parentheses. Okay, wait. So is this, so open,
Mhm.
that was.
Mhm.
Yeah. Got it. Close parentheses, Mr. Lee?
Yeah, close and then divide, and then open parentheses,
Okay.
and then do the standard deviation. All right. Huh?
Now? This one?
35, yeah. Because that's our sigma, right?
Well,
And then divide square root of whatever N is.
the second square root,
Mhm.
second square root. Oh, shoot.
I'm not gonna lie, Danny, you're gonna get mad partial credit, but you're not gonna get this whole question right. First off, where's step two? Where's the step? Where's the test statistic?
Oh, right here. The test statistic is right here, it's 1.8084. And then the p value is,
Is that okay?
yeah, so. 860, and then I just make sure this is bigger, my p value is bigger than alpha, so p value is bigger, we do not reject the null hypothesis. When it's bigger, when the p value is bigger, we do not reject it, right? We do not reject the null.
Open parentheses,
I don't know. I just need it straight.
close it now.
No, close before the 41.
It needs to keep this time.
And then divide. Yeah.
Okay, say it again, Ms. Lee.
Open parentheses. And then 47 minus 41, right?
You got,
Close
the
parentheses.
first answer.
Means apply.
1.08.
Open parentheses. And the standard deviation.
No, you got anything else? Got anything else? And what about your p-value? What is your p-value?
And the bottom.
You can do it on the table, you
Then
can do
second square root.
the calculated section data, I got the identity.
And then,
I divided the square root,
Yeah.
I mean.
and then close parentheses, close
The
parentheses.
third one.
And so,
P-value.
huh?
I just go.
Yeah, we good. Just doing a problem.
I
got locked up.
Then my B hypothesis, my
Only.
B is
Oh.
so 41, and then.
Your first name, then your last name.
Is.
Password.
Yeah, username and password.
Here.
Same thing. First name, then last name. All lowercase.
Second.
As one word, no space, no nothing.
So
Then
obviously, I have a
enter.
question.
Mhm.
So
While
all the
longer
time, we're gonna,
is
sorry,
Sorry.
all the time we're gonna do, close my,
For
close.
this calculator, yeah.
Hold on, a minute, I'm about to,
I didn't know how to get this.
Oh, if
Oh, how'd
you
you-
don't know
how'd
how
you
to
get
do
that?
that,
I wouldn't copy that.
Huh?
I wouldn't copy that.
So I got it like this. So I go to here, right?
Well, let's finish this off. Hold on, let's finish this off.
Okay.
So the next thing that I wanted y'all to do, right? Plug in the numbers. So we have what? 47 minus 41 over our standard deviation, 35, divided by the square root of our n, which is 40. All right? So let me see if you did it right in the calculator. All right. So from the calculator, we got this 1.084209483. Is everybody cool with getting the z-test value? We good? Just type it in the calculator. Click, 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 and that's it. All right? So now, step 3. How you got what? Oh, we're not there yet. He on like step 5. We on step 3. You know? All right. So now for step 3, right? I want my p-value. And my p-value is going to be the probability of my z-test something 1.08. What's the inequality symbol that I'm going to write for here? I want to find the probability of my z-test. Right? Yeah. Am I doing greater than, less than, or not equal to? Which one? Less than. How did you say? How do you know it's less than? You don't need the paragraph.
I don't need the power.
No, it's right there on the board. You literally just have to copy. It's right there. What is the inequality symbol? Huh? It's not equal. What is it? It's not less than. It's greater than. How'd you know it was greater than? Oh shit, that's all right. That's the answer. Because it's right here. Right? Whatever your alternative hypothesis is, shit. I don't know why that happened. Whatever your alternative hypothesis is, right? That's what the p-value for the probability will be that. Right? Mm-hmm. Oh my gosh. Hold on. Yeah, I know there ain't that much grass on BCC, like for real. I know he hot as hell outside too in that big ass white suit. Right? So whatever your alternative hypothesis is, that's what your probability is going to be. All right. Somebody do this for me or tell me what to do. This is greater than, so what do I have to do? I have to say it again? No, what did you say? I didn't hear because of the grass. You have to subtract it from 1, right? This becomes 1 minus the probability of my z less than 1.08. Right? So this becomes 1 minus 0. What? 0.8? No. Look it up. Look it up in the table. Look it up in the table.
This is 0.88.
Mhm.
And then you go all the way to.
Oh, yeah.
Mm-hmm.
do 1 minus in total, only in total.
No, that's different. That's different. You used your calculator, so you just got the answer. That's fine. Right? But if you're not using the calculator, you have to use the table. You have to do the 1 minus. Yeah.
And that's why I use the
Yeah.
one.
Listen,
Yeah.
Mhm.
I went over to 0.8.
No, you go one minus and then 0.8, right?
1.08. So find 1.0 and then find 8 at the top. And where do they intersect at?
And then go over to 0.8,
Yep. What's the number?
85.99.
That's it.
I go down is the go, so go down and over.
Mm-hmm. So you said 85.99, right?
Yeah.
And then what's 1 minus 0.8599?
85, 88.
Y'all know I'm just faking it with this math, right? I don't really know that. 1401.
What is it?
1401. That's your p-value. 1 minus 0.8599. Like just type it in the calculator and you'll see it. Yeah. All right, step 4. Mm-hmm. I got you. Mm-hmm. Right there? Mm-hmm. 2. Right. Mm-hmm. And then you just look up the 1.08. Right? Mm-hmm. Right, from the answer. Mm-hmm. So now step 4, right? Decision time. I want to do my p-value. VALUE, right? I want to do my p-value versus my alpha, right? P-value is a 0.1401. My alpha is, I don't even remember, 0.05. Which one is bigger? Right? Because 5 cents is bigger than 14 cents, right?
Right?
Which one's bigger, 14 cents or 5 cents? 14 cents is bigger? All right. So if my p-value is greater than alpha, what do I do?
You change it, alternate.
No. What am I doing to my null hypothesis? Am I rejecting it or am I failing to reject?
This is hello one.
Mm-hmm. What am I doing? Medical? No, not the medical. Let it go. Yeah. So, but this one, the P is high. So what does that mean? What is that? Am I rejecting the null hypothesis or failing to reject? Failing to reject. So I fail to reject my null hypothesis. It'd be less than. It'd be like this. Yeah. We have more examples. Yeah. All right. Step 5. Interpret it. I failed to reject my null hypothesis. So what's the interpretation? I would accept that. I would accept that. I was looking for you guys to say that there is not enough statistical evidence to conclude that the null hypothesis is false. That's your interpretation. Questions on this, anybody? Are you good? For homework. Because now is Jovine's time. Huh? Well, if Jovine wants to do it with you, she can. Yeah. Mhm. It's one question on test three. Yes, one question on test three. Yeah, it's 5 steps. Yeah. All right, so we good? I can take this down? Good? All right. Well, y'all have enough information now to